Okay, we are in the second part of the solution for this project here. So I'm just going to keep going. If you missed the first part, just go to the previous video, and that's where I start making the circuit. All right, so let's do what we need to do. This AC input, that is fine. I'm going to copy this VDC bulb here. Now, to make sure that you actually select the part, you want to select here. Move the text out of the way if you have to, and hit Control C on your keyboard to copy it. Control V to paste, and you can paste it any way you feel like, but paste it where something makes sense. So that's at the top of the schematic there. I'm going to bring these components down, and now we have the wiring. So hit W on your keyboard for the wiring shortcut, or the place wire shortcut. Let's connect the center of these two resistors to the negative port of this operational amplifier. I'll put the output of this op amp into the input, the positive input of this other one. And then now we also have this negative part going back into the output of the same op amp. Let's see what else we have here. Connect this to the non-inverting input of this op amp U3A. I'm going to escape and align these components with the inverting part of the op amp. Now I'm going to terminate this here, and I'm going to copy this AC input with Control C, then Control V that. R to rotate it, and then drag it right on there, and it's connected. Next, let's go with VEE. So I'll probably just move this text out the way a bit. Hit Control C to copy that and then paste it. So why do we need these two voltages, VEE and VCC? Well, it's because the operational amplifiers operate on power, and the power needs to have, for this particular op amp, the power needs to be negative and positive same magnitude. So we'll just wire that up. Okay, looking good. I'll drag this capacitor up a bit, and I'll drag this resistor value so you can actually see it. That's very important. Whenever you do a schematic, you want all the parts to be visible in that schematic. So we'll do W, make some connections here. All right, that looks good. Okay, now put the connection there. This is looking fine. Make sure I place a ground over here. I forgot to place grounds at different spots on the schematic for these components, but you need a couple grounds if you're following the schematic, of course. So this capacitor and resistor connect to the output just before this other capacitor. And actually this capacitor on the bottom here connects to this other strange capacitor configuration. So I'm just going to connect it there, make a vertex, place it right there. Next is the R8 into the potentiometer, then the ground symbol, hit G again, place it right there. And then, as always, the VCC, copy it, paste it right where the other op-amp needs its power supply. Alright, that's looking good so far. So W to continue wiring, or continue placing wires. Then we have an input that's going to get ready to work here. So put this inverting input into this resistor, and then put this into the capacitor here. Next, we'll look at this. Alright, connected there. Then this capacitor gets connected to this one. Make sure split that connection with this resistor here. Now it's a little crooked, this connection, but that's fine. And there's a resistor coming out here, just click connect it right there. Next, put this output into the capacitor and put the capacitor into this resistor. This will be our output node, and you'd use your net alias to name this node as well. So I'm going to copy this VCC, paste it there, and then VEE, select that and then paste it over here. All right, this is getting to the home stretch. Drag this ground around a bit. And then this potentiometer, we want this to grow to ground as well. Okay. Let's see what we have here. Our voltages are set, our components are set, and we need a couple more wiring steps here. The non-inverting part of this op-amp needs to go all the way to basically the beginning, the non-inverting part of this other op-amp. So make sure that that happens. Okay, now let's go with a net alias name and call it out. So place out right here. And then what we'll want is some voltage probes on this circuit. So what I'll do is, just before I do that, we need another VCC on the top here. It's a good thing I caught that. I'm sure there's something else I didn't catch, so like this wire to this other VCC. Great. All right. So now, and then this thing. Okay. Okay. So I'm sure I missed something. Yep, and it's ground. Okay. Good work. Now finally save this project. Let's create a new PSpice simulation profile. There we go. All right. So we'll name it sweep. In fact, we'll call it AC sweep. All right, so my simulation settings are open. With the settings open now, choose the AC sweep noise. And under general settings, choose logarithmic. Start frequency is 1. End frequency is 200K. And the points per decade, let's make it 20. Click apply, then OK. Save this project. Put a probe here and put a probe right over here. See what results we get for this bandpass filter. Alright, so it doesn't like some net listing error. Sometimes you might get that problem or that error. What usually happens is PSpice will highlight the offending part or object. So you can look over here, unconnected pin, no float property or float, EC6 pin 2. And then there's also EU1 pin V negative. So if we go to U1, see, it doesn't have a VEE. Highlight the green circle and delete it. And then let's give it the VEE. I know VEE is ground, but it doesn't hurt to make it general like this. So in case you do need to change the lower voltage of the op amp, it's not always tied to ground. It is tied to an alias or different signal name instead. Okay, so for this missing connection, this actually goes up to this point. So I'm gonna click and highlight that circle and delete it. And there we go. So if we run the simulation again, then there should not be any errors this time. The netlist generation is complete according to the status window on the bottom here. Okay, so with the simulation getting started and running, alright, so that's very interesting. That is the signal we end up with. So minimize this. Let's place some more probes somewhere. So let's go with the input here. That I forgot to tie to the output. Interesting. Forgot to do that. Let's see what the signal looks like, even though it's technically not correct. Yep, forgot to tie that to the output. So if you hit W, tie that on there. Whenever you make a circuit change after simulation, I encourage you to delete all the probes before running that simulation again. You might get into some weird buggy errors that takes a while to fix. Just double check it and make sure I have everything correct. Yeah, looks good to me. So once that's saved, now let's do a PSpice simulation profile again. Alright, I'll put some probes here. One on this location, another one on this V output, another one on this V output, and lastly, but definitely not least, the out node. Okay, so it's 1 megahertz signal. And what might have gone wrong in building this schematic? We have our signal here. This is going to the output. So there are a couple of things here that are wrong with the circuit. First of all, I need to break this connection so that it loops back to where it's supposed to. And the connection between these two circuits, or these two nodes, actually needs to work this way. So I'm going to delete this, make a connection from here to, let's delete that, drag VCC up a bit, and make a connection from the VCC to this top resistor. I'll make a connection from the center of this resistor to the non-inverting input of this operational amplifier. Next, we have the output here and also the inverting input that are connected to each other. And that is quite fine. I also put a resistor down here. There's supposed to be a 1 mega ohm resistor to handle this circuit feedback, or at least this operational amplifier feedback. From the looks of it, it looks a bit better now. I believe there might be something else missing, but we'll see how the simulation turns out. So just wait a few moments. And there we go. So this is the circuit that you want to build. And it's a nice, beautiful band pass filter that allows a certain range of frequencies and a certain bandwidth across, while cutting off the lower end frequency and the higher end frequency. And this is perfect for listening to audio. And if you want to actually build this project, it's quite fine for you to go ahead and do that. You have the schematic made already, and then you can go ahead and maybe make the PCB on your own. And definitely you can do that as well. All right, thank you for working through this project. I know it was kind of long, but now you know how to do a simulation for the LED organ or a bandpass filter.